Hey guys, Mrs. Traver here. We're gonna work on our notes on 10-4, solving radical equations, and we're gonna jump in with a couple examples here. There will be like 4 types of problems that we'll address. So we're gonna do 2 of each of them. So let's jump in. The first one is the square root of x plus 7 equals 16. The main thing here we're going to see is we're solving equations, and what happens to be a radical appears in there somewhere, so we have to deal with that. So our goal here is kind of a 2-step process. First thing we want to do is always isolate the radical. So we'll get that by itself. And then after we've got that done, then we can square both sides. And when we do that, then the square root will be gone, and we'll be able to solve as usual. All right. And then lastly, when we get an answer, we have to do one more thing, which is check our solution. Because sometimes there are extraneous solutions or extras. So let's follow our steps. First thing we want to do is isolate this radical, get it by itself. So we need to move our 7 to the other side. So on the left, we just have square root of x. And on the right, we have 16 minus 7, which is 9. Now that our radical is isolated, to get rid of the square root, we need to square both sides. So the square root of something squared will cancel, and I've got just x on the left. On the right, 9 squared is 81. So the square root of what is 9? The square root of 81 is 9. Next one, let's do negative 5 plus the square root of y equals negative 2. All right, let's see. We want to get our radical by itself first, so let's add 5 to the other side. That way, that square root of y will be by itself on the left. On the right, negative 2 plus 5 is 3. To get rid of my square root, I need to square both sides. So now on the left, I have the square root of y squared, which is just y. On the right, 3 squared is 9. So this first kind, pretty straightforward. Get the radical by itself, square both sides, all done. The next type are kind where there's 2 radicals happening. So number 3 will be, actually, hang on, I'm going to not get to that example just yet. Let me do a different one first. Sorry. Oh, actually, I can leave that. The square root of 8n plus 9 equals 7. We'll do 2 radicals in the next one. So let's see. We want to get the radical by itself, which it already is. So we can go ahead and square both sides. On the left, the square root and the squared go away, and I just have what's left on the inside, 8n plus 9. And then on the right, I have 7 squared, so 49. Now I can get the solve as usual down. So as usual, we would get rid of the 9 first. And then we would divide by 8. So n equals 5. We need to check our solutions here. So let's see, check our 5. If we were to check it, we're just basically plugging it back in. So in the original problem, it was 8 times n plus 9 in the radical. And I'm going to put a 5 in there. So we've got the square root of 49 on the left and 7 on the right, which the square root of 49 is 7. So this is good. We kind of like checked these verbally. But sometimes when there's a lot of things going on, you might want to check it on paper. All right, now we'll do one with 2 radicals. Sorry, I lied to you before. So this one, let's do square root of 5x minus 11 equals the square root of x plus 5. So in this case, we still want to follow our rule, isolate the radical or radicals, depending on how many you have. We have 2 right now, and they're both isolated. There's one on the left and there's just one on the right. So if I square both sides, they'll both go away, and I'm left with just their insides. 5x minus 11 equals x plus 5. So now we can solve like normal. Get all your variables to the same side. Let's move x's to the left. And then get all your numbers to the other side. Let's move 11 over. 4x equals 16. 4 times what is 16? It's 4. Let's do a check again. So our left side was the square root of 5x minus 11. And our right side was x plus 5. So we're checking 4 to see if that works. So if I plug a 4 in, on the left I've got 20 minus 11, which is 9 in the radical, and the square root of 9 is 3. Over here, 4 plus 5 is root 9, so 3 equals 3. Checks out. There's my answer. So far, all of our answers have worked in these problems. There will be some where they don't, so we do have to check it every time. Don't skip that step. All right, let's move on. Number 5. Let's do square root of 3y plus 8 equals 2. So it kind of looks like the top ones we did. Let's get our radical by itself. So subtract 8 from both sides. And then we got a radical by itself, so we can square the left and the right. On the left, I've got just the inside, 3y. On the right, I do need to be a little bit careful. When I square this, I need to make sure I think of it as if it's in a parentheses. So this isn't negative 6 squared. It's negative 6 quantity squared. So this is negative 6 times negative 6, which is positive 36. If I had not had the parentheses, it would be a negative 36. So that is important there. You have that in. All right, getting y by itself, let's divide by 3. So y equals 12. Let's check this one. So if I plug in a 12 in there, let's see. 3 times what plus 8 equals 2. Our x is 12. So we've got the square root of 3 times 12 is 36. Square root of 36 is 6. 6 plus 8 is 14. But 14 doesn't equal 2. So this check shows us that this is actually not a solution. And our answer is that it's no solution. So if you check it and it does not work, you can have an answer of no solution. I want to go back, though, and point out, way back up here in this step, we could have stopped there and noticed it was no solution, but I wanted to work it fully out to show you. So in this step, let me rewrite it without my work around it. It said 3y equals negative 6. Notice it's the square root of something equals a negative. When is the square root of anything equal to a negative number? Let's think about this more closely. The square root says something times itself, like we're looking for something times itself. If it was, say, a positive times a positive would have been a positive, so that wouldn't have worked. If it was a negative times a negative is still a positive. So the point is we can't ever have a square root that produces a negative number. So at this point, we could have, if we were clever, noticed that was the case because it was a square root equals a negative, and right there been done and said no solution. But we proved it to ourselves by solving it out and then finding out that it wasn't the case. So that's one of the changes that can happen there when we check. There is one more type of problem that we want to get to, so we'll do a few more examples of those. Here it comes, number 6. N equals the square root of n plus 12. So this one is going to look a little bit different than the last ones. It looks normal right now, but it's going to end differently. So we've got a radical by itself. Let's square both sides. So on our left, we have n squared. On our right, the square root and the squared go away, and I just have n plus 12. Notice what's different here is there's a squared sign. So if we're solving and we have a squared, this means we have a quadratic. We're pretty good at factoring quadratics from chapter 8, so let's make this look like it normally does, where all of the terms are on the same side. So I like this left side. Let's move these terms over so that they live over here with the n squared. So n squared minus n minus 12. And on my right, I have nothing left, so equals 0. So I emptied out one of the sides and set it equal to 0. Now, like I said, we're pretty good at factoring quadratic, so let's do just that. We're going to find factors of negative 12 that add to negative 1. So factors of a times c that add to b. So factors of 12, let's think 1 and 12, those aren't 1 apart. 2 and 6, those aren't 2 apart. 3 and 4 sound good to me. And the 4 will have to be negative, and the 3 will have to be positive for this to work. Because we have a 1 out front, we can just jump right to n plus 3, n minus 4. So let's see, either this one, okay, let's see, something times something equals 0. A number times a number equals 0. The only way to get 0 when we multiply is if one of the two of these is 0. So either n plus 3 is 0 or n minus 4 is 0. So if n plus 3 was 0 and we solved, n would have been negative 3. If n minus 4 was 0, then n was 4. So in this one, we have 2 solutions. And when we check, we have to check both of them. So let's check negative 3 first. If I plug it into my original equation, n equals the square root of n plus 12. So plugging my negative 3 in, I've got negative 3 equals the square root of 9. Square root of 9 is 3. 3 does not equal negative 3. So that's out. That is extra. It's actually not called extra, it's called extraneous. Let's check the other guy. So we've got 4 equals the square root of 4 plus 12. 4 plus 12 is 16. And the 16 square rooted is 4. So 4 does equal 4. This one's good. So we only have one solution here, and we had one extra. All right, so we could get 2 solutions, and then one of them is extra. Let's look at the next one, number 7. X equals the square root of 6x minus 5. So again, square root sign is isolated, so we'll square both sides. X squared equals square root and squared side, those cancel. Let's get everything to the same side. So I've got x squared minus 6x plus 5, and I emptied out the right side. So I can factor. Factors of 5 that add to negative 6. Well, to get a positive 5, either we did 2 things that were positive times each other or 2 things that were negative that were times each other. But to add to be a negative, they had to both be negative. And to make a 6, I would have had to do 5 times 1. So negative 5 and negative 1. Oops. So just like in the last one, either this piece was 0 or this piece was 0. And I can solve on each of those. So either x was 5 or x is 1. Let's do some checks. So if I plug a 5 in, I would have 5 equals the square root of 6 times 5 minus 5. So 5 equals 6 times 5 is 30, minus 5 is 25, and the square root of 25 is 5. So this one checks out. So this one's good. The other one, though, let's plug a 1 in. 1 equals the square root of 6 times 1 minus 5. So 1 equals 6 times 1 is 6. 6 minus 5 is 1. And the square root of 1 is 1. So this one also checks out. This one has 2 solutions. Let's do one more and we'll call it a day. I'm going to start it up here to give myself a little bit more room. So how about we had x minus 1 equals the square root of 10 minus 2x. Just like on the last couple, my radical is already by itself. So we can square both sides. We'll square the right. And then when we square the left, we have to square the whole thing. So I'm going to put a parentheses around it. So here's what's special on this one is you cannot go x squared minus 1 squared. That's not the case. This is actually a FOIL. So we need to think of this as x minus 1 times x minus 1, right? So on my left, that's what I've got. Let's FOIL it. X squared minus x is minus 2x. Negative 1 times negative 1 is plus 1. And on the right, I just have what's in the radical. Let's get everything on the same side. So move your 10 over, move your 2x over. So on my left, I have x squared. Negative 2x plus 2x, those canceled. 1 minus 10 is minus 9. I don't have any x terms. And factoring when we have no x terms looks a little sketchy unless you remember the trick. If you don't remember the trick, my advice is to write it as if you have no x terms. And then you can see you're looking for factors of negative 9 that add to 0, which we will need 3 and negative 3. So x plus 3, x minus 3. This first one will give me an x equals negative 3. The second one will give me an x equals positive 3. And then we can check both of those. So if we check this guy, we would have had negative 3 minus 1 equals the square root of 10 minus 2x. All right. So on my left, I've got negative 4. On my right, let's see. The square root of 10 minus 2 times 3. 2 times 3 is 6. Minus a negative is plus. So this is the square root of 16. And the square root of 16 is 4. So this is not true. So this is not a solution. That was extra. Let's check our 3. 3 minus 1 equals the square root of 10 minus 2 times 3. 3 minus 1 is 2. 10 minus 2 times 3. 2 times 3 is 6. So 10 minus 6 is 4. And that one does work. So we have this solution here, x equals 3. Let's call it a day on these notes. In general, our game plan is to isolate the radical, square both sides, so your radical will go away. Solve as usual. So either you will get one solution, two solutions, or no solutions. And then check for those extras. So that's the case here where you kind of cancel some out. Hopefully that helped. I will see you guys next time.